given from your desk. Because okay, some of the speakers not coming to your instance on there, which we will know as we proceed further. But one important thing which we want to indicate is that what is the final takeaway after today? We have been listening to the presentations, we have been all these things are happening. So that particular issue is very important, and that we have to discuss perhaps this afternoon, because we have got group discussions with 4 teams, as you would have seen here, with some chair, co-chair, and other chair. We have to really the lead people like, for example, Veeramani, Jyokumar, Krishnan, Vivekapti, or we have to really form certain groups among the participants here, and ultimately we should come with a sort of at least a draft document which we should be able to share among the participants, and they should be able to use this in their own respective countries in this particular region. So that summary would be at the last session, and the group leads will 16:30 to 17:30. The group leads will give that presentation. After which, of course, I would request Justin to sum up. So my request to all of you is that kindly have at least a mentally well prepared thought process which could be presented and discussed, so that within the stipulated time, like for example 14 hours to 16:30, hours all the 4 teams discussed at length, and sometimes the document comes out. So normally what happens is that in this workshop, unless it is done then and there, once we leave, it is distance always makes it the time delays will come. You send emails, sometimes you get into the body of all your other activities, and this goes into the lower priority, and nothing comes up. So our request would be that we should have a draft document by the evening, which could be, of course, fine-tuned, but a draft document should be ready, keyed in, and need to be submitted to for further perusal by the team members and the deputy principal. So with this, I once again welcome all of you. So those of you who are having long lunch jet lags, I think slowly we will be coming back to normalcy, and within another maybe tomorrow we will all be quite fresh. So with this, I once again welcome all of you, and I request to take. I just wanted to introduce a few of our colleagues who were not present yesterday. We have from our ministry, Dr. Prashant Srivastava. He is the advisor who takes care of all our activities with respect to ocean observations, IOCINDIO activities, and I would request him to give an introduction.
Thank you, Dr. Ahmed. Good morning to all of you. I'm very happy to be here and to see a very large participation from all the IOC members. Look forward to the deliberations today. Thank you.
Thank you very much, Prashant. Now we will go ahead and start with the country presentations. I would request Dave to go ahead as well.
A very good morning to one and all. Today we'll.
Sorry. Sorry, I'm very sorry. Could you please introduce?
I joined exercise myself. I'm Nabil Khanton from the Network of Climate Change in Bangladesh. I'm also working at Bangladesh International Support Network for Coastal Ocean and Climate Studies. So I do research on coastal vulnerability since 8 years.
Thank you very much. I'm I'm sorry, I really did not recognize the sorry.
Good morning to one and all. Today we will start our country presentation from first speaker, who is Dr. Abbas Basir. He is the Director General of SASA. Now I request Sir to.
Thank you. Good morning. I will be having an introduction and then Dr. Shul will be presenting the presentation. One of the dedicated programs that we have at Summit is South Asia Seas Program. South Asia Seas Program is established since 1985 and it's working in different areas. One of the areas that this program is working is coastal zone management. Under this area of activity, we have conducted many activities and recently we have planned to conduct an assessment of South Asia seas vulnerability to climate change. So of course it is at the initial stage of this activity. A comprehensive report and assessment report to get information from our member countries. This is our rule of procedure that we inform member countries to get information about their activities in this area, and then we will be assessing and we are having many workshops to validate those reports. So we are going to have such kind of activities and report climate change. But before that, we have done some general assessment in South Asia. The result of that assessment will be presented by Dr. Georgi, with the permission of the chair. I would like to request Dr. Georgi to present this presentation. Thank you.
Honorable Chairperson, good morning all of you. Presently, our Director Dr. Abbas Basir has mentioned about certain introductions. And I'm going to present over here is how we are making the coastal vulnerability ecosystems process. Because coastal vulnerability is a very large process. Before that, my presentation's outline of presentation is like this. And I would like to acknowledge because this presentation will gather the information from the lot of humanities researchers, those who have been contributed earlier, and I am presenting on the few clips from there. So first of all, about the SACEP, Dr. Bashir has mentioned about the SACEP. So also South Asian Seas Program, also he has mentioned. So now I will jump to the process of how the climate change process is occurring and how it is impacting the environment, and how in this aspect how the SACEP and South Asian Seas Program is working for the member countries. So this is the general glimpse because I say about the SACEP, it's 8 member countries, but we have been working with the marine environment. That is for the 5 countries. Countries are our member countries are Bangladesh, India, Maldives, Pakistan, and Sri Lanka. So in 1995, as mentioned by Dr. Basir, we have the South Asian Seas action plans. So on that action plan, our objective is to protect and manage the marine environment related coastal ecosystems in the region with an environment sound manner. So this is the SEAS program. So South Asian SEAS program is one of the 18 SEAS regional SEAS program, UN environments. So you can see the South Asian SEAS programs like what we are having, that Indian Oceans, the same, the South Asian SEAS program also is working for that. So that we feel that this is a good platform, so that if we work together, then it will be a betterment for this region. So why we are telling that our regionals, we always making coordination with our South Asian region, because you know the habitats, geology is have a, like a land is having a political boundary, but when you comes to the water, they don't have any political boundary. So it is common to all. So if we have like a common understanding together, it will have a we will have a better coordination about the protection of environment as well as the resources what we are using for the finding the solve problems to get the solutions. It will be in a very resourcefully. So that's why we feel that the importance of regional cooperation is highly essential for this. So now this, because we are working for the vulnerability, so I have think that okay, vulnerability of what and also the vulnerability to what. So if we see that people habitat of vulnerability, so to climate change, sea level rise and socio-economic pressures. So we think that these are all are interlinked. So we cannot think one place. So we have to think all. So that's why I have questions that how the climate is changing, whether we have changed the climate or climate been and we are accepting the climate change. Who has done the first? And another is how we can recognize this. We are telling so many times that climate been changing. How we can get the signatures? From where? And another point is that whether sea level is associated with climate change. So in this aspect, I have gathered this information. Look at this. I'm thankful that those of Units they have done so many groundwork for these pictures. You can see over here the CO2 level being increasing. At the same time, we have been accepting that this is the carbon dioxide. Earlier we used to accept, now we have accepted this one, and now it is increasing. So to what level we have been accepting? At the same time, you can see that side that the pH and the carbonate systems, air and sea. You see the carbon dioxide. So it keeps on increasing. So earlier pre-industrial time we accepted this, now we accepted this, and also we are now accepting this. So it means that we are accepting ourselves the carbon dioxide. So if we accept the carbon dioxide, then of course it is changing. See this changes. In a natural ecosystems, you see the greenhouse gas effect. It's a very good going and coming. These are the windows, because we have been shifting the really increasing the carbon dioxide to atmosphere. From atmosphere it is going to some places. So this is a small window. We can change here, but this small window we cannot change, because that's a natural process. So with that natural process, the CO2 is lies with us, what we have increased. So that CO2 makes this in the water, effects in the water, and because of this, the H as per the carbonate equilibrium of carbonic acid productions, you can see that this is, of course, this is a chemistry work, but this is the main problems lies with the increasing the pH for the effect to the ocean. So when you come to the climate change, we are telling, because climate change we know that it increases the atmospheric, increasing the carbon dioxide concentration. So of course everything is changing, because carbon dioxide gas, greenhouse gas is directly linked with temperatures. When the temperature increases in the atmosphere, so we have lot of unusual monsoons. That's dealt with coastal flooding, wetland productions, and ocean acidification that is related with the pH. When you come to the algal blooms or coral bleaching, corals are the calcified organisms, and they have been impacted by pH. And when you come to the coastal inundation and erosion, because unusual rains, because high evaporation gives the rain. So again, that's a rain occurs. So erosion, beach erosion, infrastructure damage. So when this coastal erosion and coastal melting beach rotation, we have another physical processes. So this is the process of the ocean circulation pattern. So as we are lies very close, the Indian Ocean lies very close to the equator. We have a conveyor belt changing over here. So at the same time, if we have temperature increases and this conveyor belt is merging over here, so we don't know that whether the sea level rise is because of the heat or because of this conveyor belt. So we have not known these processes, but we have been getting the signature that our coast being eroded, our sea level rises, and at the same time that our Maldives colleagues is there, that they have been very fragile with their ecosystem for the sea level rise. So we don't know how we can do that one, because we need a basic sea truth data. So if we don't get the sea truth data, we cannot capture the sea level rises or climate change activities to what extent it is happening. We cannot get that one. So when climate change occurs, so the sea is having three threads. One is warmer the ocean, another is less of oxygen, because when carbon dioxide is high, so oxygen will be less, so it is more acidic. So when it goes like this, we will get our ecosystems is vulnerable. So these are the threats I gathered from the net, and I said that because of climate change threats, what are the sectors like coastal coral reefs, coastal wetland ecosystems, and what are the impact into the human? Because since it is a very India is having vast coastline, and another 2-3 nations are totally seaside, sea locked, so they are completely depends upon the ocean. Once the resource is less, they have changed their behavior. Common people will have their changed behavior. So if, for example, if we not get the fish from the ocean, if a fisherman, then he has to think for some other things to do. So that's the human pressure we need. So we have to think why these changes is occurring. I'm just continuing this mariculture, recreation, tourism, freshwater research, all are having very impact. Say. So with this, I'm thankful that this Nicole and Claudia, they have given a very good articles that when the sea level regions are vulnerable with sea level rise, we can see these are the regions, and we are lies within these regions only. So I feel that we have to take enough measures so that we can stop. We cannot stop, but it can reduce. So in that aspect, SASEC has for this SAS region, we have so many, like from the global significance, we have globally 6% coral reefs are lies in this region. At the same time, mangroves also is lies here, around 7%. Here again, seagrass also is having. So if these things, if the sea level rise or climate change like a heat warm up or ocean acidification happen, so we may lose this. The percentage may come relatively reduced. So by considering this, we have developed this like a coastal and marine biodiversity strategy that is having so many things like ensuring ecosystems well-being, prevention of species extinction, control of alien invasive species, sustainable fisheries, and aquaculture, prevention of marine pollution, effective and equitable government of marine and coastal protected areas. So our SACEP strength is our member states. So without our member states, we cannot work. So this strategy was approved recently by our last November, and very soon it will be with our member states to implement this one. So if we implement this one, under this theme there are so many indicators, because this earlier we thought that it will be an IC indicators, but now we know that the SDG indicators are there up to 2030. So we have been managed to get a very good framework that on what aspects and on which way it should implement in a national level so as to reduce the CO2, not CO2, reduce the unusual things what we are doing in a unknowingly. So in this way, it will be very useful for ecological vulnerability. Of course, we have our vision is that one, SACEP 2020 and beyond. So our vision is which lies in this strategy. So here you can see that building and strengthening the partnerships. So that's why we are here to build. If one nation is strength is in one place, so if we want another member states wants, we are ready to willing to help those. So this is the ecosystems of vulnerability in SARS region, and we are expecting that if we the biodiversity strategy will be implementing is in the national action plans, I am sure that it will be somehow reduced. So this is my final slides. As we know that government of India is having a vibrant prime ministers. So a small kid has written that the please pass this climate change law to adopt the planning and minimum 10 number of trees. So I think we are working for all, for us, but also this picture has some speciality. A small kid is telling. It means that what we are doing presently, also we have to leave something for them. So in this way, a home tech message, we can say that it is a crucial attempt. We have to revitalize our nature. It is a personally, professionally, and resourceful. Thank you.
Any questions?
Thank you very much, Joel. First of all, I would like to thank SACEP, the Director General of SACEP, and yourself for coming here as a big delegation, because two senior managers from an institution to attend this meeting is a rich delegation. And mostly, we are very grateful for you for providing the kind support to the meeting, because taking charge of your own expenses to come here is a contribution. We do not necessarily value this kind of contribution activities. But when we have partners who sponsor the participation, who spend the time to avail the time from the office to attend our meeting, bring intellectual certain contribution, it is just a very strong contribution, and I would like to thank you for that. Now, my question to you will be, how do you see further concrete cooperation between IOCINDIO and SACEP? My own view is, having formal agreement is good, but to me what is more important is the concrete work on the ground. You have a what I would call the overlap of country as the membership of SACEP as well as the membership of IOCINDIO. And the concept of those countries are the same, no matter which body they are at the given time. So the complementary action would be to avoid duplication, and if there are already action that SACEP is already doing very well with those countries, there is no need for IOCINDIO to invest in those areas. If there are areas where IOCINDIO is already doing very well, in the same country, I believe it will be only of your credit to take advantage of the results. So that we share resources, we define what we call joint programming, co-design of activities, as we hear today. So when we are organizing future activities, we ask you to take from you your own concept, your own views in the country where the countries that are members of SACEP should not replicate. We have replicate experiences. So I don't know what your view on that, and how we can practically and we can could you have demonstrated keen interest, work passion, you attended the last session, and as I tell us, you are here to give your contribution. that the demonstration of interest of population and that is from the concrete ways of doing business together.
Thank you, Dr. Justin, for your kind words. As you mentioned, our participation here clearly shows our interest to working with IOC and also IOC. Last year also I expressed some interest for having joint program, joint activities. So generally speaking, so we can have our general MOU for facilitating this kind of cooperation. Of course, you are doing some activities that we are not able yet to do, and also we have done some activities that you are not. So exchange of these experiences are very important, and taking the advantage of knowledge, capacity, and basic experiences that you have also is very important for Saudi and for its member countries. Particularly the institutional structure that we have in Saudi, so it will help us to easily coordinate the 20 member countries at a very high level and also implement all documents that we are going to develop because it is it normally adopted by a very high level meeting through the meeting of the ministers of environment of all member countries of Saudi. So this is a general view reflection in this issue, and if you are going to have specific activities under this general MOU, there are many areas that we can work. One of the areas that I think that we can work is addressing climate change. Climate change effects on marine environment. So this is very, very important area that we recently started our activities, but it's better to have a joint activity, joint work in these areas. So, for example, understanding of the coastal hazards and also coastal impacts, as well as the mitigation and adaptation measures. All of these areas needs cooperation and coordination. And so, considering the high-level capacities that are available in the region, particularly in India, if we get this information from this country and have a general platform for these activities for South Asian region and also the wider level region. There is very good question.
Thank you very much, Dr. So I just want to indicate that on second thoughts we have a slightly modified agenda for today. What we are thinking is that we have to form something called a brainstorming group, brainstorming working group, or IOCINDIO, to give input to the UNDECADE. So what we are planning is that the presentations, three presentations, we will try to finish by 12 noon, and 12 to 30 hours we will have the formation of the brainstorming group and as to how to go about, etc. And similarly, in the afternoon also we will try to have the start from 14 hours to 16 hours, after which we will have a discussion maybe going up to about 18 hours and then coming up in the document. So what I request is that those are 40%, but three are not there. So we will try to stick to the original time of slightly reduce it even so that we try to finish all the talks by about 12 o'clock. So, it's late.
Thank you, sir. And next country presentation is from Dr. S. Nilamani. He is a senior research scientist from Kuwait Institute of Scientific Research, Kuwait.
Check. Very good morning, dear friends. I am going to tell you our experience in Kuwait on coastal vulnerability studies. Coastal vulnerability study in Kuwait we are doing for the last 3 years, and we are almost at the final stage. We are preparing a book on coastal vulnerability. It will be done in another couple of months. It will be released. So my experience, I will share the experience of our group on this particular aspect. First I acknowledge my institute and then my group and the Kuwait Environmental Public Authority for sponsoring this project. Kuwait is here. It is here, KWT. This is the Kuwait in Arabian Gulf or Persian Gulf. So we are at the northernmost point of the Gulf. So if you see the Arabian Gulf, so this is where Kuwait here. So this is about 200 kilometers, this is about 1000 kilometers, almost like a landlocked sea. So you can immediately you will know, since it is landlocked, the waves are not really very high. But then other things, some of the important things you will see. Our coastline is 500 kilometers natural, 200 kilometers artificial lagoon. The country has developed a lagoon project. So 700 kilometers is the coast. Most of the people, they live within 20 kilometers from the coast. That is thickly populated. We have about 9 islands. Biggest island is Bubian. This is the island. Another big island is Failaka. Alexander the Great, he was passing through this island. So archaeological values are there. Most of these islands, they are like Maldives, less than 2 meter elevation. So sea level rise by 1 or 2 meter means all these islands will be submerged. So this is one of the worry. And this island right now is almost empty. Government is building a huge mega port right now. And in future, they are developing this island. They are investing a lot of money. So that is why we are really worrying about coastal vulnerability because of these developments in future. So in future development, the island, one part of the island will look like this. So that is something. And this island, right now it is like this, but then this also government is planning to develop in the near future. And this island also is not more than 2 meter elevation. And then to tell you the next one, this is one project in South Kuwait, already done. This project adds 200 kilometer coastline to the people. So people build their homes in this particular artificial island. 1 minute I will spend on physical aspects. The bathymetry, this side of the Gulf, the bathymetry is very mild bathymetry. Very mild here. If you see 5 to 15 kilometers or 5 to 15 meters water depth, you have to travel almost like 50 kilometers. Very mild. This side. Other side is very steep. Here on side. Imagine we have 2 circulations, one here, another one here. So any pollution here in this part will reach to this part of the Gulf. So that is one threat. Waves, if you see the whole Arabian Peninsula, the waves of highest waves of 5 meters possible only of Dubai. Dubai, UAE, highest waves are possible here, and the waves of 1 to 2 meter highest in Kuwait. Similarly, turbidity within Kuwait itself, southern part of Kuwait is crystal clear water, and northern part of Kuwait is water like this, turbidity. Like Sundarban, turbidity 1 liter of water, you will get 3 to 4 gram of silt in northern part. The distance between north and south of Kuwait is not even 150 kilometer. Within 150 kilometer, south is like this, north is like this. Current velocity reach up to 1 meter per second. Some places around Kuwait, we have current of even more than 1 meter per second. Tide here varies up to 5 meters. So because of high tidal variation, high current and high turbidity, so the associated risk and they are all there. The another problem is Macron is outside the Gulf, but if earthquake of 9 happens here, inside the Gulf, Dubai will have a surge of up to 3 meters, whereas Kuwait we have only up to 0.5 meter. The tsunami induced surge will be only 0.5 meter. So we have to work for 3 to 0.5 meter, whereas a country like Doha, Dubai, Oman, they have to work for higher storm, higher values. See, compared to the open ocean, Indian Ocean, if you see, the seawater temperature varies from 10 to 36 degrees. It doesn't happen in the Indian Ocean, 36. Similarly, salinity, seawater salinity 48 to 50 we measure. We don't have in open ocean. Turbidity up to 50,000 ppm. So this also again you will have in Andaman, this Sundarban. So we have high turbidity. Rainfall, average rainfall is very less. Air temperature 8 to 55 degrees. So the climate condition related to the vulnerability assessment you can imagine. The lowest and highest, both of them are extreme in Gulf and particularly in Kuwait. Okay, now I will one more problem associated with vulnerability is huge amount of dust falls into the sea. The dust contains not only nutrients, also it contains pollutions and poisons. Because everywhere surrounded with oil industry, the dust falling also brings a lot of toxins into the sea. So that reflects finally the vulnerability of biodiversity. So this is another important issue in this part of the world. Now I will go into what we have done in Kuwait. As I was telling you yesterday, waves are less, tsunami effect are less, surge induced by storms are less. Our botheration is for long-term vulnerability, not for short-term vulnerability. The reason is most of the people, they live closer to the coast. So 1 meter sea level rise means catastrophe in the Gulf country. So our worry is mainly on long-term vulnerability. So now this the questions every country, like yesterday I was talking about this, every one of us will ask this question when we do vulnerability assessment. I am skipping this because of time limitation. We will discuss in the afternoon more. So we are focusing on coastal flooding or inundation vulnerability, coastal erosion vulnerability, socio-economic loss or vulnerability. Seawater intrusion is a problem, but we are not putting much effort on that. Biological vulnerability. Dr. Faisal Yamani, he is reaching here tomorrow. That group is focusing on that. So our group, we are focusing on the first 4 out of it, the 3 we are focusing. So I will do what we have done in these 3. These questions and parameters, I will skip them all. What we did is like this, 3 years, the whole Kuwait, we divided into 200 segments, each 1 nautical mile. We went to all these segments. Out of 200 segments of each nautical mile, we went there, our group with instruments and equipment for collecting data. All these segments, we did profiling. We collected soil sample to assess its strength. We observed the geomorphology by photograph and videograph. And we have observed the marine life also by photograph and videograph. So all real time, the data, field data we collected for all the locations. So this is our base. So we were very happy that the data we did is more than 80% of the data we use for vulnerability assessment is field collected data. Also we use remote sensing other data, but more field collected data. 18 months we spent in the field. Out of 200 locations, 162 locations we could do. Muddy area we could not able to enter, so some of the locations we did not do. Seaside and landside soil we collected. Recent landside soil is more focused for future vulnerability study. So this is what I was telling yesterday. There is no point using the soil in the sea for erosion studies, future erosion studies. We need to know the character of soil on the land for future erosion studies. So sea and land. Seaside and landside slope we assess. Landside slope is more important for coastal vulnerability. Seaside is not that important. So these are all the ways we did. General assessment of biodiversity, general assessment of the health of the beach, general assessment of pollution of the beach, all these things we have done. And this is a typical photograph of some locations in Kuwait. Some of the locations are like this. See, the building is just on the high water level, maybe nearly 25% of the Kuwait, the beach houses are just at high water level. So this is the biggest worry for the people in the country. Imagine 1 meter sea level rise. Already hundreds of buildings, they are all they lost their end of the end side of the beach. They lost, and we are trying to help them using environment friendly coastal protection solution. We are trying, but then government is planning for an integrated solution for the whole country. So it is like this. Some area very nice beach. Some area the beaches are like this, rocky. So if you see the wall, one house, you see, almost on the line. So like that. And some places the beach are very steep, some places very mild. So it's all like that. Okay, even this I am skipping now. I will go and tell you the final result. This anyway, afternoon we are going to talk more on coastal erosion. We will talk more on that. Sea level rise, as I was telling you yesterday, since we are uncertain about future sea level rise, we are doing the study for 3 different scenarios. 0.25 meter sea level rise, half meter sea level rise, 1 meter sea level rise. All our assessments for 3 different sea level rise, and we have to wait and see what is the sea level rise in hundreds of years. So results, see, we have some of the results I am going to give you now. See, this is geomorphology of the whole country, geomorphology. So it is a red color means they are easily vulnerable, sandy or muddy area, easily vulnerable. If you see a green color, it is a rocky coast. It is very little, only some local patches are rocky. Otherwise, the whole country, from geomorphology point of view, it is very highly vulnerable. This is our conclusion. And from coastal slope point of view, if you see red color, the slope is mild. Red color is here and here, mild slope. Mild slope is very vulnerable from inundation point of view, first of all. So we know where will be the highest inundation, basically from the slope point of view itself. So very highly vulnerable. So these are all artificially, the lands were raised during constructions, so they are little bit low vulnerable for sea level rise. Third one is wave height. Wave height information, some of the areas, these areas, protecting area, little bit more vulnerable, low vulnerable. So we have this result. Tidal range, the highest is here. So highest tide, lowest tide of 2 meters is here, 5 meters is here. So in our way, highly vulnerable is this area from tidal range variation. From sediment type, what is low vulnerable, what is high vulnerable? Our focus is on erosion. Smaller the sediment, lesser dense, very easily vulnerable from erosion. So that is what the classification we use here. So that way, very coarse sand, wherever you see green color, they are very coarse sand, meaning they are less vulnerable from erosion point of view. From sediment point of view, less vulnerable. Where you see red colors are here, and some of the area here. Very, very fine sand, easily vulnerable for erosion from sedimentation point of view. Then from inundation point of view, these are all the area which will inundate very high. For example, these areas, 1 meter sea level rise, the inundation will be 2 kilometers, very mild beach. 2 kilometers is a sea inundation of sea into this red color area. Where you have green color, not much, very, very small patches here. The inundation will be order of 10 meter. So 10 meter to 2 kilometer for 1 meter sea level rise. So we have identified those areas. They are all purely based on field measurements. So accuracy, we believe in the accuracy. Then the physical vulnerability according to USGS formula. So red color indicates physically they are vulnerable. As an engineering sense, I cannot tell whether it is erosion vulnerable, flooding vulnerable, no. Physically vulnerable. So it is not for a decision maker, just for a basic understanding of any human being, physical vulnerability. So that way, from my experience, I say this is not really needed. That doesn't convey any useful message, physical vulnerability. But still, we thought we should just do as a sake of exercise. We did that, and this is what it is. And the coastal economic activity. So we have one plot, economic activity based on the economic, petroleum industry, all the other industries. Economic activity. So highest economic activity or red color. So anything happens, sea level rise or erosion, these are all the key places for economic loss. So this is a map of economic activity. Then this is the one I wanted to spend 1 minute. Erosion vulnerability index. So this one is, we started from the basic principles of erosion. All the parameters we collected, wave height, soil particle size, slope information, all the information which are all contributing for erosion, we collected. We ranked them according to its weightage. Then finally, we did this assessment. This what shows, this is the area really we have to focus. The decision maker, if you see this figure, he knows immediately this is the area he has to go for protection in the future from erosion. Reason, this is the main area, industrial area also, petroleum industry area also. So a clear indication for decision maker, this particular plot. The decision maker need not to focus on these areas, not required to focus. This is a focusing area from the erosion point of view. So now it is up to them whether they will go for artificial protection, natural protection, or any innovative type of coastal protection. It's all up to us. So we have the information, clear information of the whole country on hotspots on erosion. And this is another economic vulnerability index. So this is mainly for decision maker. We made it for decision maker. The reason, see how we made this, mainly, this is a preliminary, we have to do some work. The land cost in the coastal area, we collected from the government. Square meter, what is the cost of the land at each and every space, we collected from them. And we know what is the vulnerability of inundation, we know. Each location we know. So we multiplied this and we came up with a figure. This is an interesting figure. 1 meter coast, if 1 meter coast, I walk on the coast like this, 1 meter coast, this is stretch. How much is the loss for the government if sea level rise by 1 meter? So that is the information we give. This information, the highest value is order of $2 million. 1 meter coast, if sea level rise by 1 meter, government will lose $2 million. So this is what a decision maker needs. So if he knows $2 million for a meter coast I lose, then he will think, okay, can I spend quarter of this money to raise this particular land to prevent it from inundation. So that is what the very important message to the decision maker from this particular plot. So we have done this for the whole country. The decision maker know where he will lose the money, where he will lose less money. So this one we are very happy to do this because very informative information. And conclusion, in another few months we are going to publish the book. The book will contain more information than this. And then from our experience, what we can contribute, all our experience related to data collection, analysis, the way we made it for the information. If you see this information, it is available for scientists and engineers. It is available for a single user who owns a 5-star hotel or a good entertainment facility on the beach. A single person, information is available. So they can get decision for the whole decision maker of the government. So we have information for all the three type of stakeholder for the benefit. Thank you very much for this opportunity.
Thank you, Professor Kerapalli. I think this has been a very good work done by UNDECADE, which I think all the member states could really adopt. Questions? Okay.
Thank you for your good presentation. You said in your presentation that there is a huge amount of dust fall in the sea. I want to find out, I want to know what practical measures have you taken to tackle this problem?
Okay. We have one group in our institute, they work on dust related issues. They are trying to grow a lot of trees at the periphery of Kuwait, the tolerant trees. The temperature is 8 to 55 degrees. Some of the trees are tolerating. They are planting a lot of trees, not only Kuwait, almost all the Gulf countries. If you fly over Dubai, you will see rows and rows of trees. So it mainly catches the particle which is moving from ground to some 10 or 15 maximum meter. But then the dust takes off up to 200 meters. So those dust we cannot do anything. So we have to live with it. So the dust, that group is doing what type of pollution that the dust contains. Imagine it contains mercury, cadmium, all those type of dust. And you see, I want to tell you, in 1 meter square, in a year, 200 gram dust falls. Imagine, in a year, in 1 square meter. So this much of dust falls into the sea. So we have to live with the problem. Yes.
So, you use two keywords in your presentation. Health assessment of beaches, health assessment, and also general pollution of beaches. Can you tell me more about it?
I don't work on this, but I know the university medical department,
What are
they work on that. And there are some good publications. In fact, we refer those publications when we are doing this work, just for our own knowledge. A lot of people in Kuwait, they suffer with breathing problems because of that.
Okay, so they are, it is quantitative analysis of the health statute of the beach, or it's just...
It's everywhere, particularly in summer. Sometimes when you come out from your home, within a meter you will not see anything. So that is our test. 1 meter you don't see anything.
Sometimes.
Yeah. But the information is, out of 1 year, almost 200 days are dusty days. 200 days. But intensity is from this to this. You know, 1 meter visibility less than this is only for 2 days. But then, anytime you one meter tip of air, you take it filter, you will find some dust. So it is very, very good. Yeah. PM 2.5. Most of the days, from 200 days, you will take it.
Sir, just one nice input. Actually, here the video factor the sensitivity adaptive capacity of the that I would check.
No, that end area still we have to work. Adaptive capacity, resilience area.
That area is still we have to do. You have advanced, so you have to catch up.
I think due to time constraint, we discuss more. Thank you.
Yeah. Thank you, sir. Our next country presentation is from Dr. Sidney Thurston. He is a program manager in Ocean Observing and Monitoring Division, and he is from Noaa, US.
Good morning, everybody. I'm Sid Thurston. I'm with the United States National Oceanic and Atmospheric Administration, also known as NOAA. And for the next 15 minutes, I'd just like to briefly go over 3 points I'd like to make. One is NOAA's long-term commitment to the region. Perhaps many of you don't know that NOAA's been working in the Indian Ocean for over 20 years, over 2 decades. NOAA's been actively involved in the Indian Ocean for over 20 years. The second point is I really think you need to take a holistic look across the entire Indian Ocean basin to look at coastal vulnerability. I don't think you can just look at the coast. We need to see what's going on inside the Indian Ocean as well. And then I'll wrap up with several coastal vulnerability and coastal resilience initiatives that NOAA is doing for the United States that will translate nicely to this Indian Ocean region. So let me go ahead and get started. Of course, NOAA is committed to the United Nations Decade for Ocean. I'll be leading the working group tomorrow for a predicted ocean. Just a short introduction to NOAA. We take it from the sun to the depths of the ocean. That's NOAA. That's the United States National Oceanic Administration. We're an agency that enriches life through science. Our reach from the sun to the seafloor helps to keep citizens informed of changing environment around them. We have 3 S's. Our mantra is science, service, and stewardship. So it's not just basic research, it's applied research. For example, how many fish are in the sea? These are questions NOAA answers. What will be the weather tomorrow? How about 10 years from now? What's the weather 100 years from now? 1,000 years from now? These are applications, and these are practical problems that NOAA is solving every day. And of relevance to this workshop today, are we wisely building on shifting sands? So this is the program I help manage. It's Global Ocean. We are the only agency in the world that has a global mandate. We're responsible for putting in situ ocean observations in all of the ocean basins around the world. And we provide about half of the in situ ocean observations for the world. These are the things I think we need to start looking at when we consider coastal vulnerability, coastal resilience. I think you need to look at, the monsoons. You need to look at the Mad and Juliet oscillation. Right here, the MJO, which begins in the Western Indian Ocean. The genesis is in the Western Indian Ocean. It propagates across the Indian Ocean, across the maritime continent, across the Pacific, and it has a huge impact on the United States subseasonal to seasonal weather forecasting, S2S. And that's one reason NOAA is so involved in the Indian Ocean. Tropical storms, tropical cyclones, they impact the coast as well. That's what you need to be thinking about, I think, when you're talking about coastal resilience. Indian Ocean Dipole, global impacts, natural oscillation of warm and cold water across the Indian Ocean, but it has precipitation and temperature impacts globally, including the United States. IOD is another reason NOAA has been working in the Indian Ocean for over 2 decades. There'll be many others. Nick is familiar with the Ningaloo Niños, Decadal Basin Oscillation. I won't go over all these, but there are many things happening in the Indian Ocean Basin that affect the coastal Indian Ocean and also impact globally. This is the Indian Ocean Observing System, and we'll be talking about this during the UNDECADE meeting later this week, and then we'll have a big workshop in Goa in March. And I'm actually the chair of the Indian Ocean Observing System Resource Forum. You can see some of these networks. Argo floats, Rama are the moorings across the Indian Ocean, and I'm the program manager for the Rama array, and I'm a program manager for the Surface Drifters array, globally, not only for the Indian Ocean, but globally. NOAA's making big investments in the Indian Ocean Observing System. So NOAA's been contributing for over two decades. NOAA signed the Indian Ocean Global Ocean Observing System, IOCINDIO, MOU in Mauritius in 2002. And then, as I said, I chaired the Indian Ocean Observing System Resource Forum. And it's a real honor. It's a real honor for me to do that. I really enjoy it. So these are just some of the U.S. floats in the Indian Ocean. This is May. You can see the light blue are the drifter buoys, and then the dark blue are the Argo floats. These are U.S. assets in the Indian Ocean. So this is what I manage for NOAA. This is the Global Tropical Moor Buoy Array Program. And what I'd like to draw your attention to, this is in 1999. Not a whole lot going on in the Indian Ocean. And just 10 years later, you can see we have Rama significantly implemented. How did we do that? Well, it's from resource sharing partnerships. We've been working with Japan, we've been working with India, NIOT is our strongest partner. And thanks to Dr. Atmanad, Venkat, Srinivas in the early days, India NIOT is our strongest partner. We work with Indonesia and then some other countries. And you can see we're 91% implemented now. We just have the Western Indian Ocean here. And then we are very pleased that India, their Omni moorings will become part of the Rama array. So the name will be the Rama Omni Tropical Moor Buoy Array Program. We're very delighted with that development. So this is our India partnership. And I won't go over all of these, but we established this in 2008, so we've been doing it 12 years now. We just had our 10th anniversary celebration in Goa at NIO. Secretary Rajivan was there, and then the NOAA Administrator, Deputy Administrator Craig McLean was there as well. Our 10th anniversary. This is the umbrella agreement, and then Rama is, of course, a cornerstone of that partnership. We got our flagship, the Noaa Ron Brown, into the Indian Ocean for 2 months. For 2 months, our premier NOAA vessel was in the Indian Ocean, and we had a week-long port call in Goa to coincide with our celebration. We recently implemented 3 new moorings in the Arabian Sea, and we're also working with Indonesia in the Eastern Indian Ocean as well. So strong partnerships. Our newest partnership is Korea Institute of Ocean Science and Technology. Just to wrap up the background before I get to the coastal vulnerability, we also believe capacity building is hugely important. We've helped organize over 30 workshops across the Indo-Pacific region to demonstrate the use of ocean observations for improving tropical cyclone forecasting, sea level rise, floods, droughts. We really need people to understand the importance of ocean observations for society and economy. So these are just some of the workshops that we've had in Africa, Western Indian Ocean right here. So back to the coastal vulnerability piece. This is NOAA's strategic goals, and you can see oceans, which I've gone over a little bit. Weather, I've gone over climate. So let's focus now the last 7 or 8 minutes here on the coast. This is one of 4 priorities for NOAA, is the coast. And these are the 6 questions that we're supposed to answer for this presentation. What's the vulnerability profile? In your opinion, what are the priorities? What data information are available? Are there any gaps? And then what expertise can you contribute and what expertise do you need? So let me go over this quickly. What's the vulnerability profile of the United States? And this is just from NOAA's perspective. This is not from other US government agencies. But sea level rise is a big concern. Sea level rise is a big concern. So let me go over this right now. The current state of science is a decade's worth of sea level rise. They're catching up with the development. The infrastructure of the United States is starting to feel sea level rise. We've categorized this, again, this is NOAA. We've categorized this into minor sea level rise, moderate, and major. And I will not go over all the details at this point. You will be able to have a copy of the presentation, and there are many additional slides in the presentation that are not, I will not be presenting for the interest of time. So you can see here for this level, we are describing coastal flood advisory. This is a coastal flood warning. This is a coastal flood warning. It's basically depth of water, the severity, and how much of a threat there is to life and property. In your opinion, the problem related what's the priority here? So this is the accelerating threat of tidal flooding. And you can see here in the 60s, there was minimal, really, concern about sea level rise, and the curve is shifting. This is height, mean high tide water. Yes, thank you. So you can see it shifting and becoming a concern in the United States. Sea level rise, and again, these are the three categories. So for example, in the 60s, there was very little nuisance flooding, but now in the 10s and the 20s, as we are now, we're getting more. And in the 60s, there was really not much moderate flooding, and now we're starting to see that. So this is a big concern. So what data information available does NOAA have? And where do I get NOAA tides and currents? And again, there's a lot more slides in the presentation, so I recommend you take a look. But most of our information is drawn from NOAA's Center for Operational Oceanography Projects and Services. This is called COOPS. And we have a number of products that I think you'll find useful. High tide flooding, historic tide and tidal currents, and then sea level trends. I think this may be most applicable to the Indian Ocean region. I recommend you take a look at this website right here, the sea level trends, global map depicting sea level trends. This is a sea level rise viewer as part of the U.S. National Ocean Service Digital Coast. I think this is another rich source of data that you'll find interesting. This digital coast, this is the website right here. And you use this web mapping tool to visualize community level impacts from coastal vulnerability, photo simulations of how future flooding will impact your activities. And this is the website for the NOAA Sea Level Rise viewer. So gap areas. I reached out to many of NOAA's sea level experts, and they're really excited to work with IOCINDIO experts. That would be you. So I want to make sure that while I'm here this week, we exchange business cards and we reach out, because they know you don't know what you don't know, right? And they know they can learn a lot from you. And that's what they're really excited about, is cross-pollination, exchange of information. What you're doing in the region can benefit the United States, and what they're doing in the United States can benefit the region. areas which you can contribute. We are working with a major international insurance company. AXA XL is the name of the insurance company, and we developed an Ocean Risk Index, ORI, designed to quantify the fiscal impact. So this is more of a monetary and economic impact of physical and marine biological changes along multiple coastlines. The index will be designed for use by policymakers to catalyze behavioral change, and you can read the rest of that. But it's a major new index. I think it's just about a year old. A second major initiative we've done is this National Coastal Resilience Fund. $30 million are set aside. NOAA contributed some, and the U.S. National Fish and Wildlife contributed some money as well. And this will restore, increase, and strengthen natural infrastructure along the United States coastline. Areas in which you require expertise. Again, NOAA experts want to meet with IOCINDIO. They want to contribute and exchange ideas and thoughts, your best practices, in exchange for what we're doing in the United States. With that, I'll say thank you. And this is about 1/3 of the slide deck. I wanted to keep it in time, so if you get a chance, get a copy of the PowerPoint presentation. It has a lot more in-depth information. Thank you.
Thank you, Dr. for the excellent presentation of overview of NOAA, which is only a tip of the iceberg. You know, for discussion during that time, but
Please, Justin.
Thank you for this, I would say, this overall presentation. Thank you for coming here. And I should say that CIDE is here, many of us. He's here representing Noaa, but he's also here representing IOCINDIO, because we are happy to have IOCINDIO with us, because it has been a major driver for the activation of IOCINDIO. Because it is not how to have a community, what makes a community alive is the program and activity. And IOCINDIO projects are very active, are doing real science in the region, and we really rely on the IOCINDIO leadership to boost ocean science development in the region. So thank you for being here also on behalf of IOCINDIO. And it is also here the capacity of the leadership of the US in the UNDECADE. So in all this big capacity, we want to thank you. Now I want to just jump on your last part where you say, Noaa expect we give you an IOCINDIO. I'm not sure I will well understood what you mean by that, but the whole view is that if there is any possibility where we can have a small meeting with leading scientists of postdoctoral in IOCINDIO, Noaa expect that to be very, 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 very good. I'm sure that Noaa is contributing 50% of the World Institute of Observation. Science, technology, innovation. So have lots to share. I'm trying to say that from your starting point, that you don't know what you don't know, which is very good. So to go there, we get building over the next decade, was on 9.7 years. So I'll try to do that.
Yeah. Did you want to follow up?
No, I actually, I'm compelled to just intervene and sit, on behalf of the IOC elements that I'm involved in, which are the Indian Ocean. Specifically, I want to congratulate you, but more appropriately is actually thank you, and for everything you do for the Indian Ocean. And for the International Indian Ocean Expedition, for all of its aligned projects. Not quite sure what we'd do without you and your underpinning NOAA support. That was a fantastic presentation, some of which I found new and interesting. So thank you, Sid. I really appreciate it. I just want to put on record openly that you're very appreciated.
Indian Ocean is very important. Indian Ocean is very important. Not me personally, I think it's going to be the premier basin during the next UN Ocean Decade. I think it's going to step up and the spotlight is going to be shining. To Justin's point quickly, I want to get everybody's business card. I want to start building the bridge by email to our Noaa scientists, coastal scientists, reaching out to you. And then look for opportunities, international meetings you're going to attend, Noaa scientists are going to attend, and then you can start building those bridges. I think that's a practical way to start. I'd love to say, we have enough money to hold a huge workshop, we'll all get together, we all know the realities of that. So please give me your business card and we'll start a dialogue. I know many coastal scientists that would love to be in contact. And then also look for international workshops that you're attending together.
Thank you very much. Questions? One. Thank you. Thank you.
Thank you, sir. Our next country presentation is from Dr. Sergey. He is the head of the Center for Coordination of Ocean Research, Russian Academy of Science, Russia.
Ladies and gentlemen, I want to present some Russian experience in the field of coastal zone saving. Russia has a very long coastline, and as you see, 39,000 kilometers in whole, and we have long coastline in the Arctic, in the Far East, and also we have some coastline in inland seas, Baltic, Black Sea, and Caspian Sea. But Russia has not coastline in Indian Ocean. And last years, Russian scientists work not so much in the Indian Ocean as some time before. So maybe my presentation is not quite in frame of the working group agenda, but I think some our experience will be useful. Having so long coastline, Russia has many problems in saving coastal zones. Among them, in the Arctic, we have problem of thawing of permafrost and improving of increasing removal of sedimentation from the coast to the marine environment. The next one is hydrocarbon pollution and the development of oil and gas offshore. This problem is on Far East, on Sakhalin, and in Caspian Sea, and begins in the Arctic. shore. And many problems what discussed yesterday here, there are in Russian Federation too. So I will stay on everyone, but I will should say that what in Russia we do to save now the state of coastal zone. Now we have every year expeditions in the different seas of the Russian coastal zone. But this expeditions is on research vessels and covers every seas, Arctic seas of Russia, from White Sea and Barents Sea till Chukchi Sea. Everywhere we have expeditions. Also, there are expeditions in Far East coastal zone, in Japanese Sea of Japan, Tatar Strait near Sakhalin, in Okhotsk Sea and Bering Sea. And also we have expeditions in inland seas, in Baltic, in Black Sea, Azov Sea, and Caspian Sea. It's a huge of work, really, but this three slides shows only scientific expedition. This is science only for science. The science is not for sustainable development, because we have a huge amount of data, new data received from the expedition. New discovery of new species, biological species, new mineral deposits on the shelf. But it's very interesting and very useful for all of us. But this, I repeat, it is science only for science. To change understanding of our people, usually people ask, for what do you science? For what science need for me? And scientists often cannot answer for this question. So our task is to change understanding as for scientists that the science need for sustainable development, understanding of business, community, and population, that science need for sustainable development now, for achieving sustainable development goal 14 for ocean and for coastal zone especially. I show some key approach to coastal zone saving, what we understand in Russia now. First one is creation of system of continuous monitoring state of coastal zone. The expedition, what I showed in the first slides, months annually, but they have an appointed position. And for monitor changes in the coastal zone state, we need continuous monitoring of this state. We have one system, I will show. We have one testing area on the Black Sea now, where such system consists of about 7 years works. It consists of many equipment. Different characteristics, parameters of the seawater in the coastal zone measured. And main of the this equipment is special aqualog. This is first of all, I will say why this is area near Gelendzhik. Gelendzhik is a area for the population rest, and there are many beaches, and people come here to rest. And near from here, there is Novorossiysk, a very big port of Russia, one of the biggest port, where many pollution comes to seawater. And so this testing area can monitor everyday changes in the this shore zone. We have here different equipment, and main of them is aqualog. I'm sorry, this I used the Russian language on the slide. I received it from my colleagues and have no time to change it. But I will show the aqualog later. This is more profiler on the it may be stayed on different depths from close to the coast and on the depths till 2,000 meters. And profiling is include different parameters, can measure different parameters of seawater. It depends on sensors you include in this equipment. This is one example of the variability of vertical distribution of temperature, salinity, and density during half a year. And such distribution we have already during 7 years. So the task is to create such system in every vulnerable point of the coastal zone, along in Arctic, in Far East, in other seas inland. The next approach is formation of maritime clusters in areas most prone to environmental damage to coastal zones. Why? We have a forum in not so long ago. We had forum in Novorossiysk where participated presenters from different organizations from Southern Seas. Forum named Sustainable Development on the Southern Seas of Russia, from organizations from Black Sea, Azov Sea, and Caspian Sea. And unfortunately, the forum was not international, but many different people participated in them, including students from maritime institutions. And the main was adopted a resolution on the forum. Was resolution pointed some positions of what we should to do in the nearest future to improve the sailing of the coastal zone or in the different areas. You can see this. One of the proposals on the forum was to formate a maritime cluster in Novorossiysk. Novorossiysk, as I said already, is the big port, but around the Novorossiysk there are very wide rested area. Many beach, many interesting places. So many different representatives of different structures from government, from business community, from scientific community, and coastal population should be involved in this cluster to discuss and to change, to develop jointly the work on the saving of the marine area around this place. The next one approach is conducting outreach to the coastal population on the importance and necessity of maintaining the marine environment in available state, combating coastal pollution with human waste. Really, people don't understand that sea is now already very polluted, and it's very important to change understanding of the people living on the coast that they should help to clean and to help to save the coastal zone, especially for them. And very important point is international cooperation with surrounding countries along the coastal zone, because the cross-border transfers along the coast depends on activity of every country. The forum, as I said, was not international, but we hope in the nearest future to organize some forums on the Black Sea. But we had already the meeting of all 5 countries of the Caspian Sea to join efforts for investigation and saving the state of Caspian Sea. And it's a very important position. I should point that I used for presentation data and pictures from different marine institutions of Russia. And thank you for your attention.
Thank you, Dr. Sethi, for the overview of any questions?
Sir, you talked about aqualog mode buoy, okay? How many transects you are monitoring? How many points, like to get in a special picture of your coastal zone? Suppose let us take example of Haute Sea. How many you have?
Yeah, now we have in Russia only one testing position. But as I know, some countries buy aqualog from construction bureau. I have, if you're interested, specification for aqualog. If somebody is interested, just a moment.
Thank you. And I have another point to ask you. So, this one, for how long you can deploy this particular instrument, time period? Because how you are validating your data, suppose the correctness of the data.
Oh.
How long, once you deploy, how long you are retrieving, validating yours?
But it was deployed 7 years ago.
Yeah.
But every time on the ship we check the state of the equipment.
What is the frequency? Do you have any idea? What frequency? How many months you can go and what frequency you use? Once in a month or twice in a month?
It can work about 1 year without changing.
Okay.
But necessary, especially for condition of the place. It's necessary. It will be prepared specially equipment. Somebody needs.
Can we have it discussion after lunch and during lunch time, if you don't mind, so today?
Sorry.
Can we have a discussion after the lunch time because of the lack of time? Sorry for that.
Okay.
So thank you very much and
Thank you, sir. So next. Our next country presentation is from Dr. R.S. Mahindra. He is a scientist in Indian National Center for Ocean Information Services from Hyderabad.
Very good morning to all of you. At the outset, I thank NIOT, NCCR to give me an opportunity to present experiences of my organization in vulnerability mapping for a good cause of saving lives in the Indian Ocean region. Okay, I am from the National Tsunami Warning Center in UNDECADE, and we also provide our advisories for the Indian Ocean countries, and this is another opportunity to share our experiences or inputs to this good cause. So as we all know, December 26, 2004 aftermath devastating tsunami, Government of India has entrusted our ministry to establish a national tsunami early warning system, and with a good support from our various MoES institute and other national institute, could able to establish a national tsunami warning center at UNDECADE in a record time, and it was operational since October 2007. Okay, since we have a tsunami warning center, we have a working package called preparedness to generate a tsunami hazard maps. So for that purpose, NCCR was actively involved, and they were put their all efforts to generate tsunami hazard maps using a lot of inundation models. And parallelly, we are also looking into alternate options to get some vulnerability studies with another holistic or probabilistic kind of approaches. So with that, we all got into that vulnerability studies, and we all know that Indian coasts are very exposed to various oceanogenic disasters. We have densely populated coasts. We have 3 mega cities in the along the coast. One among them is Chennai. We are sitting here. And there are various disasters striking the coast, tsunami, cyclones. We have very frequent cyclones, and there is a now increased frequency of cyclones. Even earlier, Arabian Sea was little safe. Now we observe there is an increased frequency in the Arabian Sea as well. So that's why Indian coasts are highly exposed, and we need to assess vulnerability. These are the very important parameters. So we have many hazards striking the coast, and each hazard has its own characteristic in terms of repeativity, in terms of extent of damage. So, and each hazard is measured or monitored or assessed in different approaches like modeling, deterministic, probabilistic, and we have tsunami, storm surge, sea level rise, coastal erosion, etc. Okay. With this, for all this purpose, geospatial technology plays a vital role in assessing these hazard maps and getting out the vulnerability, finally derive a risk from various disasters. And we need a lot of data sets, and we can do overlay analysis and promote it as risk is often a risk, hazard and vulnerability often correlated, and risk is a function of vulnerability and hazard. And if we have a capacity and preparedness, we can reduce the risk from the disaster. And this is the first work which we started to understand what is the vulnerability profile or a kind of vulnerability setting all along the Indian coast. We have considered basically 7 parameters from the geological and physical process parameters, and each of these parameters were derived using the different data sets. Basically, geomorphology is derived using this code for Indian remote sensing satellite data, and for shoreline change studies, especially we use Landsat data downloaded from USGS. I should thank USGS, made many researchers and students, academicians work easier. Data is readily available and used. You can take an instantly download and use that. And in addition to that, we also use data from open domain elevation data, and slope is generated using Jet code. Most of this data is in open source, and many of the students also involved in assessing this work.
and it has also imparted training for many students. And with all these parameters, we derive an index and come out with a final CVI index using this. Each of these individual parameters were given risk ratings, and finally we derive a risk index, so CVI index, and this map is generated at a state level. And then for entire country, Atlas has been generated, maps comprising 156 maps on only 1 lakh scale, and it was released in 2012. So these basically this CVI indicates the vulnerability along the each coastal stretch. This alone may not be really sufficient for a coastal disaster management and for any operational use or planning anything. So we thought that we wanted to go further, and this work was started. Dr. Shailesh Nayak was there in our exercise as a director, and Dr. Srinivas Kumar was our group head, and he was a driving force behind all these activities. Then we went for next approach, multi-hazard vulnerability assessment. This is a kind of an holistic approach based on probabilistic. We will estimate the extent of inundation due to oceanogenic disasters. This is basically drawing a flood line due to oceanogenic disasters. Here input parameters are long time sea level data pertaining to 125 years of data, 40 years to 125 years of data for 21 Indian coastal tide gauge stations. Data is obtained from Survey of India, and this data is detailed and estimate water levels were estimated. And these were calculated a return period, probable inundation in next 100 years. Similarly, we have also added sea level onto that, what is the based on the trend, and we also consider the erosion based on the erosion trends. So that's why we call it as a multi-hazard. It combines extreme water levels, sea level, and coastal erosion. And this brought into a GIS environment, kind of overlay analysis has been carried out, and these are the data sets we use. And we also have a high resolution topographic data from ALTM. It's a LIDAR mapping. Survey was carried out by ISRO, NRSC, and this data is of 5 meter horizontal coastal. Vertical accuracy is about 25 to 30 centimeter. So that gives us more confidence in generating such maps, because when the vertical DM data is very accurate, most of these results are depending on the DM data. It's very important parameter on topographic data to have a digital high resolution topographic data. So we have that data. Yesterday Dr. Ramamurthy was telling, we have this data from coastline up to 2 kilometers. Certain areas we have beyond 2 kilometers in some deltas, but still this data is not sufficient. So for that beyond 2 kilometers, we use Cartosat DM data derived from Cartosat for 2.5 meter spatial resolution, and we also use satellite data for shoreline change studies. Sea level data was been sea level change data is calculated using the PSMSL data, and we have used tide gauge data, hourly tide gauge data from Survey of India. And some cases we have observed that some events were missing. For example, Orissa super cyclone, it was not recorded in the Paradip tide gauge. That time tide gauge was gone bad, it couldn't record that event. That's why we also included the records from the published literature as well. And there is a Noaa NGDC data set is available. From those, whatever the available extreme water level recorded were included in our model. For each of the coastal location, we estimated what is the inundation level, including sea level. And if assume suppose for an area it's a 3 meter inundation level, we selected 3 meter contour line from the ALTM data, and this is the area multi-hazard zone, which is probably going to inundate during these oceanogenic disasters. So these are the basic inputs. We have ALTM data, extreme water levels, sea level change rate, shoreline change rate, and finally we derive a composite hazard line. And we generated, this work is completed for entire Indian mainland, and we also generated an atlas on only 25,000 scale. So this is an example small area of Kadalu. This is a composite hazard line, and this is how this red area is a hazard zone. And we wanted to further take it to the next level. We have also generated land use, and we extracted buildings in that. And with that, we can generate a risk map, and also we can select useful routes for evacuation. With this case study, we thought that better to have a buildings, so that we can assess a building at risk at building level due to tsunami and storm surges. That's what our objective. Then we went into 3DCS mapping. Since we have a multi-hazard vulnerability maps are ready for entire mainland, we selected few densely built up area within this MHVM zone. These are the areas initially we selected, and for these areas we have set up a 3DCS map. So we have carried out a lot of field survey and a lot of satellite data processing and generated 3D realistic buildings for these cities. And each building is associated with a socioeconomic data for Pondicherry. That socioeconomic data comprises the owner detail, building detail, and the demographic detail. So basically this data is used to generate a kind of an index. So this is small example, what are the different 10 parameters I have shown here. And the risk index will be given for each of these individual parameters. What is the building type, it's a lecture, pakka, moderate, and what is the age of the building, how old is the building, and the construction type, wall type, roof type, foundation type, number of stories, total persons living in that building, how many seniors, how many children, because these are the more vulnerable age group during a disaster. So with this, we can also, now we have developed an application in real time, given tsunami run-up heights. Based on the tsunami run-up height and the vertical location of the building from MSL, whether it's on the low-lying area or like elevated area. Considering all these individual parameters, we come out with a risk index and they generate a building level risk due to tsunamis and storm surges. So a standalone application is also developed. Because we have done this for our operational purpose, because since we have tsunami warning center and storm surge early warning system, so to strengthen our advisories, improve our advisories, and it will be very useful for the disaster management. So these are the application outputs. We can run the models in real time, and we can estimate the flow depth at each building due to tsunami and storm surge. And on the fly, we can estimate the building level risk due to tsunamis based on the actual scenario, and we can generate outputs and send it to the disaster management purpose along with our So we all assembled to good cause of saving a life. There is a vulnerable element, we have an hazard, it's exposed, there is a vulnerable element, and we have to work for preparedness to rescue the vulnerable elements from the exposed area due to hazards. So, thank you. Thank you.
Thank you, sir. Our next country presentation is from Dr. Muslim Mukli. He is the Assistant Professor in Department of Oceanography, University of Chittagong, Bangladesh.
Good morning. Till now we have actually lots of in-depth information and presentations from respective countries and from the organizations. So I will try to make it shorter because we have lots of presentations to be concluded by afternoon. So coastal vulnerability assessment and experience in Bangladesh, we are going to present by 3 of our participants. Before my presentation, I just love to show you this picture because I love it. We need to take care of the coast because of the coastal vulnerability. That's not the only importance. The most important thing is that we are living the planet because of the ocean. So we should take care of the ocean and the coast to save, because the ocean we need for the future we want. So this is where Bangladesh is. You know, we actually sandwiched by Himalaya and the Bay of Bengal in between. So lots of vulnerabilities are there. So we have India in 3 sides, and the Bay of Bengal is the exit, we should say. And the country is composed of all of those scenarios. We have hills, mountains, plainlands, rivers, crisscrossed, but the Bay of Bengal is the most important one. So this is, Bangladesh is really a watershed. So the water coming from the outside of the country, like even China, the Himalaya, goes through Bangladesh and it falls to the Bay of Bengal. So that makes it as resourceful as well as it's a vulnerable one. So the coast is 710 kilometers, the Bay of Bengal from east to west. And the coast is actually classified into 2 categories. One is exposed, which is directly connected with the ocean, and the interior one, which is also salinity induced and is also impacted by the coastal vulnerable situation. The coastal area is 47,000 kilometers, which is almost 1/3 of the country's mainland area. And we have 64 districts, and 19 districts is under the coastal area. This is how Bangladesh is impacted for the last decades. You see, most of the devastating cyclone in the Indian Ocean, born in the Indian Ocean, hit at Bangladesh. And if you see, you can find out in 1970, we have lost 300,000 people in one night. And in 1991, 138,000 people in a night. And I was also a sufferer because I was living in an island, which is the Shundip Island. It's here, which is the zone 1 for the cyclone. And we lost 26 people from my house in 1991. So most of the red colored and yellow colored, you see the devastating cyclone, storm surges, even 10-meter high storm surges hit at Bangladesh. And that's why not only the life casualties, we have lots of economical casualties and resource casualties as well. Geomorphology, you know, Bangladesh is one of the most dynamic, geomorphology, because if you just see this data, which I was reviewed during my PhD, it says we have a rhythm, you see. So in each 5 to 7 years, we have erosion, net erosion, and again accretion, erosion, accretion. So that's huge. I mean, in an island, I will show you, in an island, if we see, we are sleeping, dreaming that in the morning we'll see a new island. Or we'll see my house has already gone. It's like every year, we have lost, every year almost 3,000 meters, square meter is eroded. So that's huge. For the sea level rise, you see most of the coastal area is under 3 to 5 meter sea level. So if there is a 1.5 meter rise of sea level, total population 17 million will go underwater. And that would be 16% of the total land. Salinity intrusion is increasing every year. You see there is a publication which shows that 73, 2000 and 2009. Everywhere the area is extended up to the mainland. So that's another vulnerability. So there is a predictions like from 2013 to 2050, how the coastal area especially is getting vulnerable more and more for exposure. And this is work done by me and my colleagues, and it shows that this island was 579 square kilometer. In 1979, only 290, and now it is 250 only. So it's more than half of the island has already been eroded, and the 350 meter per year, the 3.15 square kilometer per year between 10 and 13. But there are some attempts taken by the researcher how to protect or rescue. So my colleague who worked with the help of the technical support from the Wageningen University in Netherlands, so they successfully did one experiment. If they create a breakwater reef, artificial reef with some soft intervention, and they found some positive results. That could be one options they can, the government can apply. So the coastal hazards in Bangladesh is mainly triggered by climate change, which is actually inducing sea level, salinity intrusion, cyclone, storm surge, land erosion, coastal flood, and of course the pollution, because plastic, litter, or heavy metals in most of the river in my country is, in vulnerable levels. In my country, only for the coastal vulnerability is not focused yet. But in most of the national vulnerability assessment, in a whole, coastal area is given emphasis. So we have 3 plans by the government. One for the multi-hazard risk vulnerability assessment. The other one is nationwide climate vulnerability assessment in Bangladesh, and the latest one is Bangladesh Data Plan 2100. In each of these plans, the coastal area and coastal vulnerability is given emphasis, but there is nothing especially for the coastal vulnerability protection or measurement. So that's a lacking. So we have only these few works developed by the government working with the international agencies. Everywhere environmental issues, social issues, and economic issues and climate change issues are given prioritize, and in the climate change issues, tropical cyclone, tidal surge, sea level rise is the prioritized issue. So this is the national plan for the disaster management, because we have a Ministry of Disaster Management and Relief. So main emphasis is given for the after events, not before events. So that's the problem. But now that ministry is divided into 2. So national plan for disaster management started from the ministry up to the union, the unit, smallest unit of the administration. So what's the limitation? The limitation is that most of the researcher in the university or the research center, they can do the research only for a short time, for the project period or for the thesis or the research. But they couldn't continue the research because most of the agencies who are responsible to do this long-term monitoring, they are under the Ministry of Defense. So it's not so easy to get data from the Ministry of Defense for a continuous monitoring or doing nationwide data. And most of the government agencies, they have not that much, collaboratively working with the university and research centers. We have only one oceanographic research center established 2 years back, the National Oceanographic Research Institute, which is now trying to get enriched and take the leadership of this research and development. So the coast of Bangladesh is very vulnerable in the sense of all of those hazards, and that is not only for it is in risk, that is for because it is also full of opportunities. Because in my island, Shondip Island, where we have there are lots of people, like 400,000 people living in one island of 250 square kilometers. So one time in Europe, the experts were asking me, is there any goal that so many people are living there? And I said because of the livelihood is so easy and there are opportunities for them. So there are lots of opportunities are there. So it has a great importance since prehistoric times for its abundance of natural resources. Coastal zone management is very necessary for our country. So integrated coastal zone management, sustainable development of coastal region can be taken. And for this reason, various coastal management programs have been taken for the sustainable development and conservation of the diversity and natural resources. Thank you so much.
for the presentation. Any questions?
Can I ask?
Okay.
Now, the point is, you talked about the population. Means, as I understand, your country is the highly densed.
One of the most
population.
densest country.
Yeah, one of the highest in the world. So, having said that, so do you have census? Definitely, you have a census.
Yeah,
what is the pattern of your population growth?
It is increasing.
No, what is the percentage in the last 100 years, or and how the land is changing?
Land is always decreasing.
So I think you should have some interrelation how the land patterns are land use pattern with your population growth. Maybe when you are analyzing your risk factors, maybe those points are to be taken care of.
Yeah, that's a good idea. Good things to consider. Thank you.
Okay, thank you very much, sir.
Thank you.
Thank you, sir. Our next country presentation is from Dr. Ahmed Rashid. He is the Director of Maldives Meteorological Services.
Okay. Thank you, Chair, Honorable Chair. Good morning, all of you. First of all, I would like to thank the organizers and all those who supported my participation in this very important forum, and also the great hospitality that has been provided by the local organizers at the National Institute of Oceanography, NIOT. Well, my name is Ahmed Rashid and I work in MoES Meteorological Service. Maybe slightly different from the other presentations because my background is meteorology, so I will be focusing mostly on the meteorological and marine meteorological related events that we face in MoES. So before I start with my presentation, to those who may not be familiar with the Maldives, so this is actually where we are located, small island nations, southwest of India and Sri Lanka. And we have about 26 atolls which are made up of 1,192 islands. About 99% of the total area is sea. So very small islands of this size, very small. And our population is average height of the islands are about 1 to 2 meters above mean sea level. So very vulnerable to climate change and sea level rise. And our population is almost 400,000 as of December 2017. On general, we have two seasons, that is southwest monsoon, that is rainy season, running from mid-May to November, northeast monsoon from January to March. On average, we get to northern islands 1,700 millimeters of rainfall. On southern islands, we get almost 2,000 rainfall. And distribution of rainfall during dry season is relatively less. On wet season, that is southwest monsoon, we have higher rainfall over southern atolls than the north. So, maybe I get it wrong. Now, some of the natural hazards that we commonly experience in Maldives are listed here. That is heavy rain and flood, thunderstorms, strong winds and rough seas. Sometimes when the winds are becoming with strong winds, most of the transport from one island to another is by sea, so it becomes very difficult to travel from one island to another. Tidal and swell surges are very common in these days during mostly during southwest monsoon periods, a wind of about 20 to 25 knots create waves enough to inundate islands very frequently when during southwest monsoon period. Funnel cloud and water spots are also spotted mostly during the transition seasons of the monsoon. And tropical cyclones, even though they do not directly cross Maldives, but they form very near to Maldives. And this is the Hockey cyclone which formed in the east of Maldives and tracked to the Arabian Sea. And a very recent, even two cyclones forming at the same time in the Arabian Sea is very rare event, but it has occurred in last year during this period. And earthquake and tsunami, we are also prone, we are affected by the 2004 tsunami event, so we have the potential of the tsunami, the hazards, tsunami as a hazard. And the other one, as we are very low lying, the threat of sea level rise is also is there to notice. And as I am present in Maldives, I would like to be, not from my area, but I have taken this from the State of the Environment report prepared by Ministry of Environment and Energy. Coastal and marine environment forms the bedrock to our economy, providing food security, employment, income, and recreations. So we have a total atolls including lagoons 21,000 kilometers. Reef area is 4,000 kilometers square. In coastal and beaches, land makes up to 1% of total area. Over 80% of land is less than 1 meter above mean sea level. Over 80% islands face erosion issues, and 116 islands reported erosion in 2014. And wetlands, we also have wetlands, 74 islands with wetlands or mangroves. Total area of wetlands is 1.4 kilometers. And strengthening coral reef monitoring is important for conservation and management of ecosystems. Limitation in technical and financial capacity barriers the regular monitoring of these reefs. And biodiversity-based sector contribute about 89% of GDP and 71% of employment and 98% of exports. Maldives has a rich marine diversity with several species which are globally significant. We have 14 species of mangroves, birds, 167 species, and turtles, 5 species of turtles, fish, 1,200 species. And there is a threat of loss of habitat. Maldives has designated 42 protected areas totaling more than 24,000 hectares and designated as biosphere reserves. Effects are ongoing to convert entire Maldives to a biosphere reserve. And we have protected several species of fish from exploitation. And also some of the threats that higher SST posing the bleaching is a threat to coral reef, coastal modification including sand mining, cutting channels, reduction and harbor development, etc. are threat. And also the reef lagoons are being reclaimed. And here I will look at some of the historical events that we have faced in the recent history. There was a serious well surge in 1987. This affected mostly all the central Maldives. During this event, there was no major weather systems, but it is expected to have originated from southern Indian Oceans. The wave has originated in this area and propagated towards Maldives and affected the islands. And the second such event was surge in May 2007. Similarly, in this event also there is no major weather events in the Indian Ocean area, but very high waves affected the islands And this also has model shows that it has origin in the southern Indian Ocean and propagated towards north and affected Maldives Islands. The third such case was in April 2008. During this event, there was a tropical system in the southeast of Maldives. So this has created swells that propagated towards the island and affected, inundated many islands of the region. And the tsunami that we all are familiar with in 2004, our islands are severely affected during this. Almost 82 died and 56 missing. 13 islands were destroyed and 56 islands sustained major physical damage due to flooding. Over 2,500 houses were destroyed and more than 3,000 others were severely damaged. And most of the effects were tourism, as our major income is from tourism, fisheries, agriculture, and among the hardest hit sectors due to this event. And here I would like to show some of our weather observation capacity currently exists. We have manned observations, 24-hour manned 5 stations in different locations in the Maldives, and 36 automatic weather stations of this type, observing weather every 10 minutes, and 1 up-air observation radio sounding stations located in the southern Maldives, and 1 Doppler weather radar, and 3 tide gauges to monitor the sea level changes in the sea level. And these are some of the products that we use in weather forecasting. We have a work model running locally at our server, and we also get numerical weather prediction models from regional and international centers. And RISE provides regional interest, international multi-hazard early warning system, also provides numerical weather prediction models, customized ones. ECMWF, European Center for Medium Weather Forecasting products, are also being used. And there is an ongoing project initiated by WMO, Severe Weather Forecast Demonstration Project for South Asia. It is website is hosted at the Regional Specialized Meteorology Center at New Delhi, IND. So for this project, also ocean-related products are provided from MoES and other products from the developed countries. And there is also a specialized section of INCOIS providing ocean-related information to Maldives domains. And other products from Indian Meteorological Department also being utilized in weather forecasting. These are some of the products that we use from different sources. And some of the major economic sectors that we cater for the regularity and safety of their operations are aviation sector. Aviation, almost 70% of our services goes to aviation sector, customized products for their safety and regularity. Sea transportation, which includes the fisheries sector and also the normal travel from one island to public transport, and also to the tourism activities, outdoor recreational activities, and also in the water sports category. And some of the challenges that we have in our weather observations, at present we don't have any marine waves and current observation stations at present. So we have very much difficulty in monitoring this wave and current over the region. We mostly depend on the model products. We don't have to validate such models also. And limited observation from southern Indian Ocean for monitoring ocean state and swell. As I have seen a lot of observations from different organizations, but we are not able to utilize them, as sometimes we don't know where the data is, or sometimes we are not able to produce the graphical outputs from such data sets. So that's why we need some of the trainings to discover and utilization and visualization from various data sets for local applications. Training on numerical weather prediction models, ocean and atmospheric models are also required. We have a good setup of automatic weather stations, but frequent data gaps are there due to failure. So we need to train our technicians to maintain and calibrate the automatic weather stations. And also we have limited human resource and technical expertise to maintain observation network locally. So we need some support in training our technicians to maintain our automatic weather stations. These are some of the, this is one of the very big project that is being supported by the government of Italy, and we are given some components of this project enhancing weather and climate monitoring and data management capacity of Maldives Meteorological Service for reducing vulnerability to climate change in the Maldives. Under this project, we are given 4 components to Maldives Meteorological Service to enhance our services. So we have installed 25 automatic weather stations, which is completed now. And there is another component development of mobile application with command alerting protocol enabled features. This also completed. Now we are testing its functionality. And there is an ongoing component of the project development of wave forecasting system for Maldives archipelago. This is ongoing. The development is going on. And there is another component, integration of all the data that we have. This component is approved and we are in the development of the component. With that, I end my presentation. Thank you.
Thank you. Presentation of the beautiful country of Maldives. I think one of these meetings in the course of Maldives so that we can have
No, just to comment Dr. Rashid for coming because I know that his preparation to be here was very short and he has been very committed, very motivated to come. And it is good for us to have Maldi attending for the first time since we started the ratification procedure. The legislation was well taken, and we know that at home we have also the National Protection Agency. That is a very good job. Together with the National Agency working together, and the chairman said, "God, we're happy to visit your country to organize a motion there." So we are very happy to welcome you to IOCINDIO. Thank you for coming.
Thank you for the wonderful, nice presentation. My question is for the beautiful coastal country, and you also said you don't have enough manpower to take care of all the vulnerability aspects protection. Is there a plan, comprehensive plan from Maldives to develop the capacity of the manpower in the near future? Short-term and long-term plan to increase the capacity, manpower capacity to take care of all these issues?
Yeah, actually our department has not done much, but our ministry, our parent ministry has started some programs with our national university. So their environmental management program is supported by the ministry. So a lot of students are involved in the environmental management program. So those graduates are being taken to the ministry once they complete them. So that is an initiative by the ministry so that we can utilize them in the future work that is being carried out.
Thank you. Thank you very much.
Thank you, sir. The next country presentation is from Professor Emel Hamza Shafai. She is from Apex University, Tunisia.
Good morning. Good morning, everyone. a bit complicated. So, good morning. It's my first time in India, and I'm really very happy to be here in order to be able to share some experience. I would like also to present my deepest thanks to the organizers for their huge work. So, today I will talk about marine pollution and its impact. So I will tell you some stories and also I will share some experiences. First of all, Tunisia is located in the northern part of Africa and in the southern part of the Mediterranean Sea. Last night I did some calculation in order to see the ratio between India surface and Tunisia, and I found that it is 20. So India is 20 times larger than Tunisia. So we have 1,300 kilometers of coast, or a little bit more. And compared to other North African countries, we have the highest ratio coastal line over area. So when we compare Tunisia with Algeria, Libya, Egypt, and Morocco, we can see that we have here the highest ratio coastal line over area. So the first point I will present is about aquaculture in Tunisia. We have land aquaculture and we have also offshore aquaculture. For land aquaculture, we are dealing with three main fish species: Sparus aurata, Centrapus labradus, and Colon labrosus. So it's increasing every year. Of course, it is for the national market. 1 kilo is sold about 3 euros the kilo on the market, and it is also dedicated to exportation to European countries mainly. So here, about fish aquaculture, we have an interaction with the private sector, proposing some solutions for disease, and sometimes we have some problems, so our laboratory was involved in this, with this sector. So about offshore aquaculture, it is also getting more and more important in Tunisia, but of course it's a solution, but also it generates a lot of problems. As we have, for example, in protected areas, there are some offshore aquaculture cages. And I think that now after the revolution, neither the government nor the political person are aware about the threat of this situation. So, the other point is about national monitoring program. We have a national monitoring program in Tunisia since 1995. We are dealing with different kinds of monitoring: toxic phytoplankton, which is called DREFI, microbiology, heavy metals, hydrocarbons, and pesticide network, and also biotoxins and parasites. So this national monitoring program is inspired from the French national monitoring program. In our laboratory, we, of course, we are working with, I'm professor at Sfax University, and with the Sfax University, we are a research group, a recognized research group, which was created in 2000, and we are working as a cluster. So this is the research group, Toxicologie Marine et Environnementale, Sfax University and the Institute where I teach since 1993. But we have also in the cluster a research NGO named AREBI, Association de Recherche Environnement et Bio-Innovation. So this research NGO I founded with my research group in 2012. And we are also collaborating with Innovation House Consulting, which is a private consulting company dealing with the interface between research and the private sector. So, since the beginning, we have a national network of collaboration and also an international network of collaborators all over 10 countries and about 17 universities, mainly European groups from Spain, Italy, Portugal, France, Turkey, but for Asia we have Japanese program with different universities, Akita University, Hiroshima University, Tsukuba and Toyama University. And with Malaysia also, we did a research collaboration with the University Technology of Malaysia in Johor Bahru. With Canada and the USA also, we have had some collaborations, but unfortunately no collaboration with India. So I hope that in the future we will have collaboration. But we have had since a few years bilateral collaboration between Tunisia and India. So they have the code. But at that time I didn't have any people that I know that are working on the same field, in the same field of expertise and who are dealing with the same issues. So we are mainly interested in these topics: the impact of heavy metals on marine organisms, heavy metals and cancer disease. We are collaborating with the Sfax Hospital and working on the effect, so we are dealing with epidemiology. We are also interested in endocrine disruptors and their effect on reproduction, pollution and reproduction in marine organisms, biomonitoring and also bioremediation. About biomonitoring, the possible compartment we can choose to monitor pollution and to distinguish pollution between one site and another site is to use seawater, sediment, or living organism. But with seawater and sediment we have some difficulties. For example, in seawater we have the problem of low concentrations. We have also the problem of variability and also the cost of analysis. In sediments we are faced to some problems such as the physico-chemical form of contaminants and also granulometry. So, in marine ecotoxicology, we generally use living organisms called biomonitors in order to reflect the pollution state of one site. So, in the case of Tunisia, we are using our laboratory already validated two biological models, which is Cerassoderma locum and Ruditapes decusatus, the clam. So these are filter-feeding organisms, they don't move. At the beginning in my PhD I worked on fish, but fish is not a good model because we have mobility of fish and we don't know. When we measure pollution in the tissues, we are not sure if it comes from this side or from another side. So here we have the two models. We also work on Pinctada radiata, which is the pearl oyster. And together with colleagues from Caen University in France, Normandy, we are working on the use of bioactive molecules, natural bioactive molecules, in order to solve some problem linked to high mortality of juveniles in summer season. We did also some work on hemolymph of Aliotis tuberculata. This is also with Caen University. So the approaches we are using, so we have a biological model, bivalve. The approaches we used are field sampling, laboratory experiment in vivo and in vitro. I don't know, perhaps some people are not biologists. In vivo, that means we work on the whole animal. In vitro, that means we use cell cultures. We have also field transplantation. We can bring the viral from one side to another side and monitor the pollution. And also, and lab transplantation, so we can transplant organ. So we are dealing also with different level of organization, individual organ, cell, molecular level. We use it, what we call, not biomonitor, but biomarkers. Biomarkers are responses. When the organism is exposed to pollution, it's able to give an answer, response. It could be protein synthesis or enzyme inhibition or any other kind of biological response. So we are using these responses in order to use them as early warning systems to evaluate pollution. So it's named biomarker, and we were involved at the Mediterranean level with UNEP and IOC in calibration and the use of these new tools. Some results. So we make also pollution mapping along the coast of Sfax. You have here the dark color for high concentrations and the less the other lower color intensity for lower concentrations. We also use mapping for biomarkers. Now I will talk about very important point, which is pollution and reproduction. I'm not sure that everyone is aware about that point, even in the biologist community, research community. So, endocrine disruptors are xenohormones, which are synthetic hormones, for example, what we find in contraceptive pills. And these hormones are in water treatment plant, but after the treatment, they are still here. And sometimes they have a more complicated configuration and more toxic sometimes. So the effect of these molecules on the reproduction is linked to the fact that they are making a mimetic action with the biological processes. That means in the organism you have xenoandrogen or xenoestrogen. They will have a behavior similar to the behavior of endogenous hormones. So, and for example, here you have some HPLC profile of fish bile and also muscle extract showing different kinds of xenohormones such as alkylphenol, estrone, estradiol, and so on. With Le Havre University, we validated a test, the use of tests called DS and DIAS in order to detect xenoestrogen activity in different compartments, in seawater, in sediment, and in organs. Some observed effects related to the effect to the pollution and reproduction. For example, here you have, in the case of cockle, you have just sample calculation of a sex ratio. That means normally in a population of organisms, you will have 50% females, 50% males, or plus and or minus just a few points. But when you have, for example, 70% of males and 30% of females, it's a problem. And even the contrary is a problem, because you will not have the regeneration of the population. Another observed result. So here, even for people who are not biologists, you have here the gonad histology in a male and the gonad histology of a female. So it's completely different. And when the organism is exposed to pollution, you will see here an hermaphroditism case. That means in the organism, the male will have some female parts, or the female will have some male parts. So it is a mixture between the two sexes, and it is a problem. Sometimes we have in the reproductive cycle a kind of disruption, and the cycle will not move on. So we will not have spawning, for example. So it's a real problem. So this is also another example. About fish, some observed effect fish sex ratio in the estuary in La Seine in France, which is one of the most polluted area. So as you can see here, the flounder, you have 39%, the goby, 34% for males, the eels, only females, and the roach, 35.9. That means here you have a real underground disruption. There are also some morphological effects observed when fish are exposed to such kind of xenoestrogen or androgen. Here you have Gambusia affinis living downstream of paper mill effluent. As you can see here, this is the normal male, the head of the normal male. This is the normal female. As you can see, there is a difference between the two. But here we have exposed female. She will look like male and female at the same time. So there are some morphological effects, and there are some deep differences in the reproduction. So the female could be masculinized and the male could be feminized, owing to such kind of endocrine disruptor exposure. Of course, not only in the marine area, all the animal kingdom effects were observed. For example, amphibia, DDT, and here you have three-legged frog. For the polar bear, as you know, that pollution travel and go till the northern, the Arctic or the Antarctic. So you have here the bear, and with PCB, there is a masculinization. What about the effect on humans? I think that we are still in the déni. That means we prefer not to think about that question. But the reality is that we have now results and research work dealing with that point. We are on the top of the food chain. So in case of pollution, we will receive about 10 at the power of 6, 10 at the power of 9 time pollution from the bottom of the food web. So here, some research showed the relationship between exposure to endocrine disruptors and some abnormalities in humans. For example, infertility, spontaneous abortion, breast cancer, early puberty, prostate and testicular cancer, reduction of male babies, and the sperm count reduction. These are epidemiological, very serious work showing that there are problems. So, other stories about Tunisia and about the Mediterranean Sea, we have some invasive species coming from Indo-Pacific, for example. This is an example of invasive species. We have also this shrimp. We are dealing with the phytoplanktonic blooms, and I'm really interested in topics such as ocean literacy in order to outreach and to present this kind of result, simplifying and vulgarization of scientific research to the large public. One last point is about entrepreneurship. I'm also very interested by entrepreneurship in life science and how we can help students and researchers to transform their ideas into business. So I think it's a very important issue. In Tunisia, we have a very high level of unemployed graduates. So for that, we have a concept, we developed a concept named How You Turn Your Ideas into Business. It was inspired from TUTEC Hamburg Center and also Massachusetts Institute of Technology concept. I teach this kind of entrepreneurship in Caen University with a student, master student in aquaculture. And during 2 or 3 days, they work on their ideas, they work on their skills, and they try to build up and to find their own professional project. So we deal with the opportunity, the problem to solve them. It's based on problem-solving approach. So I think it's an interesting approach, finding solution and so on. And for example, they work on their ideas. They draw their project at the end, and also they make the pitch, the elevator pitch, during 5 minutes or 2 minutes in order to present their work. It could be individual or by 2 persons or 3. So it's a very nice game, allowing the young researchers, young graduates to have this attitude of entrepreneurship. And I think that we should teach entrepreneurship since the primary school, if we can. Because generally at the primary school level, children are very connected to their dreams. And they know what they like. But at the university and spending so many years in research, they forget about their dreams. And they are completely disconnected from their dreams. So we need to think about that. And I hope that the UNDECADE will be an opportunity to do something in that field. Hackathon, this is our, I was involved also in this event. And coming back to the different questions, I consider that gap area, the problem is anthropogenic pressure is not under control, the lack of awareness about worrying trends, the gap between research group and real problem. Sometimes researchers, they are working in their lab and they are completely disconnected from the reality and from the problems. And also political will, of course. We need political will to be able to do that. Possible contribution from our side. We have a system of bivalve caging for pollution monitoring, solution to reduce bacterial and pollutant load in purification steps, building capacity entrepreneurship, soft skills, interface experience between research and private sector, and they have some flyers for those who will be interested, and also required expertise. Yesterday, I was really impressed by all the Indian presentation dealing with topic which is not really my field of expertise, but I was really impressed by the huge amount of result and expertise. So congratulations for what you are doing. It's really interesting, and I hope that it will be transferred to other areas in the world. I think that I finished, so some keywords, yes, I do it. Soft skills, capacity building, some few keywords to finish. Innovative project, networking, and so on. Thank you very much.
Thank you, Professor. Okay. Professor, for the study of the activities in Tunisia.
Thank you. Thank you for your wonderful presentation. I just want to find out if your monitoring system, national monitoring system, you are doing also biological studies on bloom area.
In our laboratory, we are not working on algal blooms. We are I'm just saying that in Tunisia we have also, as any in other area in the world, we have blooms, different kinds of blooms. We have a national network dealing with that topic because there are some toxic species we have.
thank you for your presentation. I have a couple of questions. You are doing the biomonitoring, and then you have used the clamps as the indicators, right? So, because I was also associated with the International Muscle Watch program, and in that, unless the clamps are depurated before you analyze for the contaminants, so you may end up with the wrong results. Like the clamps should be subjected to depuration, like the sediment which is present in the organisms should be taken care that is whether that's being done.
I don't understand very well.
Yeah, when you analyze
yes.
the clamps,
yes.
you are taking the clamps with the bioindicators, right?
Biomonitors.
Yes. So before the analysis, you need to see that the clamps are depurated, like what is present in the body should come out. Then only if you do the analysis, you get the right picture. Because that's from my experience from the Muscle Watch program which I was associated with.
Yes, it depends what is the initial question. If you are comparing different sites, you just take muscles or clams in the field and make analysis because they will reflect the reality of the site. And if it is, for example, to export to other countries, you need to make the purification step. Of course, purification step will decrease bacterial load, will decrease some contaminants. So it depends what is the question, what is the problematic. But in the monitoring program, we need to use we need to use clams from the field in order to see what is the difference between site A, B, C, and D, and so on. You understand? So you can make a cartography of pollution based on analysis made on the clams. Did I answer your question?
I'll discuss later.
Okay, we will discuss later. Thank you very much.
Thank you very much. I just indicate here that Yasser from Saudi Arabia, he come on yesterday late, so he is here now, and he has done the self-introduction. So now self-introduction, he will give a overview of the activities in Saudi Arabia.
Don't go. Yeah, it's okay. Thank you.
Well, good morning, everyone. First of all, I would like to thank Professor Admanand for giving me this opportunity to come over here. All of it's arranged for me in the last minute due to the visa issue, my health issue. I had an operation about 2 weeks ago. However, I could manage to make it and come over here to see all these beautiful faces. Just about an hour ago, Justin has asked me to prepare something. So this is just prepared very quickly, but I hope to provide you with some information about what we are having. So forgive me if there is any lack of during the presentation of some of the information I'm going to give. However, I'm ready to answer any questions and concerns from anyone of you. Saudi Arabia has a very long coastline along the Red Sea and the Arabian Persian Gulf. Its stretch is about 2,500 kilometers, 1,900 or about 2,000 along the Red Sea, and it's about 700 kilometers along the eastern side, along the Arabian Persian Gulf. So in the last 30 years, Saudi Arabia has made a tremendous amount of development of the socio-economic. Right now we have a mega projects on the Red Sea. Some of you maybe heard about it. It's called NIOT. This is a very massive project. It's going to be the economic hub for all the international country around the world. So, and it has a stretch in the Gulf of Aqaba and the northern western side of the Red Sea. So, 50% of the population of the Saudi Arabia are residents or dwell around these coastlines. So it's very important to understand what is happening in our coastline. Therefore, there's a project going on right now between the general, the authority of the General Authority of Meteorology and Environment Protection. It's called GEMET, and it's come under the Ministry of Environment, and with KAUST, which is King Abdullah University of Science and Technology, where I came from. So, basically, we understand that's the importance of the coastlines, the importance of this tremendous amount of booming and development. So we need to go and to monitor our coastline. This is the overview of the project. We need to know the long-term stability of the marine ecosystem and the increase in human population, economic growth in the coastal zone, so which exerts considerable pressure on the sensitive environment. So Saudi Arabia recognized the importance of that. So we work heavily to make a good quality of life to its citizens, and also recognize the many complex demands in the coastal zone and associated resources. So basically, we working together with GEMET to scaling the relative impact of the coastal pollution sources and other causes environmental degradation, identifying and preventing and remedial actions of any problems happening on the coastline. So the research plan, first of all, we're going to do literature review. Of course, we're going to sit with them and agree on the inception report. That's the first step. That's how we're going to work with them. Then after that, we're going to do, excuse me. After that, we're going to do some literature review to identify the main key environmental indicators, going to go through the literature regularity review, because unfortunately in Saudi Arabia, we do have some regularities and amendments, but however is not updated, is not highly enforced, there are so many lacks. Since we are moving now with the vision of 2030, there's tremendous amount of movements in Saudi. So now we would like to make these things applied well and to be organized well. So we're going to make a very heavy regularity review and update that. Once we're done with those, we're going to do some gap analysis. So wherever we have some gaps in the past, we try to cover up with that to make sure that we're not missing anything. However, we will. I mean, we're not going to complete, but we try our best. Once we are done with those, we're going to have some research field survey. We're going to do some field survey to collect data. We're going to make and identify the hotspots areas. However, we are focusing and the criteria for the hotspots mainly in the potential development areas. Then after that, we're going to make a good and future design and to make a national implementation plan for the marine coastal project, for this project. Then finally, we're going to add and hoc advices with the General Authority of Meteorology and Environmental Protections. This is the research work. Of course, because I'm going to have only 5 minutes, I'm not going to go in further in details, but I'm trying to give an overview of about what we are having in Saudi Arabia. Of course, KAUST as a university, we are capable because we have a good high technology, instrumentation. We have highly collaborations with different many well-known universities around the world. We already have some works in the Red Sea. We will apply the same in the Arabian Persian Gulf in the other side, but I'm just giving here some type of what type of services and technology we are using. We're using, like, for example, gliders, of course, buoys. We have research vessels, and of course, what other provided by satellites and data from international different sources. These are the people and the guys we train in Saudi, and that's what we are trying to do with the Ministry of Environment. We use CODAR as well. This is what we have at the moment on the Red Sea. We will apply that on the Arabian Persian Gulf. Of course, Saudi, just let me point out, Saudi, especially in the last 2 years, we are a bit concerned about any major oil leaks, because we have here, as I mentioned, heavy mega socio-economic projects. One of them here, what we call the new Maldives. So, yeah, what we call the Red Sea project. It's about more than 30 islands with many big resorts. That's what the Saudi, what they call the Red Sea projects. So we have what we call the Amala projects, is the same, and they are so beautiful. I mean, you can search in the net and you can read about it. It's not the time here to talk about it. I'm not advertising or making anything about it. However, I would like to appoint something very important. You know, you have these type of projects, and it's very important. But what happened if you have an oil leak? And if you guys remember, about 2 months ago, there is an oil tanker over here in the middle of the Red Sea. Suddenly, it's just in the news, it says that it's being hit by rockets. And we don't know the real incidents, but whatever happened to that tanker, it has an oil leak. And after about 2 weeks, some of that oil leaks hit our coastline. And we went ahead and we tried to work over how to clean it, how to protect all those areas. So imagine if those tankers or anything's happened in this area, that will hit us in our projects, in all our, what we are having here. So from now on, we are trying to be prepared, either in the Red Sea or in the other side, in the Arabian Persian Gulf. We are ready to prepare for any type of these incidents to protect our coastline and to protect our projects. So this is just like a real quick of what I'd like to say. So thank you very much for giving me this opportunity, and I'm sorry if the information I have provided is not fair enough, but that's what I got asked by Professor Justins and Adnan to give something today. and sorry for any inconvenience. Thank you very much.
Thank you, Priya, for the overview of the activities.
No problem. Thank you.
So I just I'm interested to know, maybe, so if there is, you have a lot of, as you mentioned, oil leak. Who is the department or which ministry is responsible for managing? You have any separate, for if there is oil leak in the Red Sea, so who manages? Like in India, Indian Coast Guard is responsible for management, okay?
You're right.
In Saudi Arabia?
Well, in Saudi Arabia, if you know, there is a big oil company called Aramco.
Okay.
Aramco has their own system. However, they work with us because we use very high resolution models.
No, I'm telling for management, for cleaning.
Right. For this is for predictions because you have to know where the oil is going first. Second, they have their own way of cleaning and managing the oil. However, there are 2 to 3 agencies, the port authorities, the Ministry of Environment, and comes under the General Authority of Meteorology and Environmental Protections, and we have the Coast Guard. So those people, they team up, and usually they make like kind of emergency committee, get together and work ahead to do the management of cleaning and managing the crisis. Of course, with the help of all the governmental stakeholders or any related, governmental ministry.
Thank you very much.
Thank you.
Next talk, UNDECADE from the University of Oxford, presentation. Present here, he has sent some slides which Justin has agreed to present on the
Thank you. So you now realize that I'm Justin, I'm not really Simuda, but we are very excited to present on her behalf because she has shown a keen interest to attend the meeting, and the local organizing committee tried the best for her to get the visa, but at the last minute she could not get the visa, but she has been very determined to participate in the workshop, and she sent her slide. And we believe that it is a fair credit to show you briefly, my presentation, so that I bear any responsibility for any wrong information. But we are keen to work with her because she is senior researcher at the University of Oxford. We have already developed in the past some collaboration between IOCINDIO and the University of Oxford on innovations. So we want really to use this leading university to build capacity in the region, in particular innovation, and also in what we call entrepreneurship. That's why we are keen to work with this kind of leading university of the world, like Oxford. Okay, so she is leading one of the projects between University of Oxford, UK, and some private sector together with Seychelles. And the point here is that they started the project last year, and the project will last 10 years. And they really want to showcase for Seychelles first, training young scientists in Seychelles, secondly, map and come to the result whereby in 2030, Seychelles will have about 30% of its superficie area as a protected area. These are the kind of results they are using for mapping and so forth. Again, we are having a meeting end of this month in Nairobi that will be focused on African region. And I received from her an email last night that she's willing to attend the meeting there to present. So this is not particularly on the Northern Indian Ocean, but it is more on African country. But they are also planning to have activity with India and with other countries. What is good in the activity is that they are working directly with the presidential office, and they even managed to make a diving together with the president to show how important it is for the policymaker to touch the reality on the sea. So we really believe where we're working with institutions that have the capacity to raise the visibility of the project to the level of the president, to dive together with the president on the sea. That's a really convincing argument. That's where we touch really the policymaker. So that's why we are also happy to learn from their experience. That's the first experience they are having. And just they have equipment and cutting edge industry capabilities, applied research, inspirational communication with local communities, critical capacity building, where they are bringing young fellows from Seychelles to Oxford and also training them to the university in the UK. They're working with industry and the private sector, which is very important. And my fellow from Saudi Arabia was speaking about some private sector, in particular oil industry, and the benefit of this region will be how you partner with the private sector, in particular oil and gas industry, in Qatar, in Saudi Arabia, in Emirates, and so forth, to use part of the capital for capacity building in the region. You hear that it's important to live with the private sector in the region. So this is the kind of level of partnership they are using. So that's all I can say about the presidential policy. The presentation is here, it will be distributed together with the presentation. But again here, what is more important for us is this kind of university, they have innovative approach of project management, and they also have a good and strong capability for fundraising with major industry. So the key point for here is how to bring the youth, young student, master student, to learn this kind of innovative approach with this leading university. So thank you.
Now we will move on. We have a draft all the proceedings which are happening this today's presentation is not live webcast, and it is also you can see the program also in YouTube. It will be available for you or for videos you can share with others also utilize this.
Good afternoon. So this presentation is basically to set the tone for this afternoon's group discussion. So basically, I'll just present on what we did in the previous workshop and what is the major outcome of that workshop, so that you can, based on this, you can carry on the group discussion this afternoon. So the output of this Hyderabad workshop in May was Regional Coastal Vulnerability Framework for IOCINDIO Countries. So I call it the version 1. The objectives were, since most of the countries didn't have a baseline data, first we thought an assessment of coastal vulnerability due to climate change across different aspects like temporal, geographic, socioeconomic, all that was necessary. So that was the first goal. And the second thing was to facilitate exchange of data between the countries. So these two were identified as the major goals of the last workshop. And then it was broken down into different tasks. So basically 3 tasks were identified. So the task 1 was to first create a database, coastal hazards and exposure database. So that was the reason why we asked for the country profile of each country when we presented this slide. So the first thing was to identify the hazards and the exposure database. So that was identified as task 1. The task 2 was, then we thought a regional methodology was important. So we took an online survey and found out some of the commonly used tools, and that we proposed as task 2. And the third was the mitigation and adaptation pathways that each one can adopt. So basically the framework had these 3 components which were broken down into 3 tasks, 1, 2 and 3. So one was the database, which was to create the baseline data. Second was to create a regional framework using available online technologies. And third was to adaptation pathways that each country could decide for themselves. So the task 1, that is coastal hazards and exposure database, primarily deals with setting up a database of hazards and exposure elements collated from various sources in their own country. So the objective was to create a geographically referenced and catalogued coastal hazard and exposure database for a country. So this we thought was the basic step that a country had to do. And the major activity was to collect data on historical hazards, climatological parameters, socio-economic infrastructure and things like that. So this was identified as the first task in the last workshop. So how to set up this thing was the primary source. We thought GIS would be the basic tool. So in a GIS database, how we can set it up, how we can set up a central repository for all this data, all that was discussed. So the first task, if a country didn't have it, this was the first step, that is to create a database using available data sets that were available in their various departments. So this was agreed upon as the first step. Then the second major objective was what are the first technologies that are available that you can use directly from the net for this study. So the second task was called as coastal impacts, vulnerability and risk assessment to deal with the methodology that can be adopted to map this vulnerability. Okay, so we thought we just divided it into 2 levels. One was the regional country level coastal vulnerability atlas for those countries which didn't have it, or for countries which did have it, like how UNDECADE has already done for entire country. You can identify hotspots for in-depth vulnerability analysis. So different levels were set up depending upon the expertise available in each country. So for those countries which didn't have a general regional framework, so we thought these 3 would be enough. So these are all online tools that are available from various sources like Noaa and things like that. So a coastal hazard wheel could be used, or a coastal vulnerability using INVEST model could be used, or many index-based methods were available. So one of these could be taken up to set up the first regional level assessment for a country. So for the second task, for first level, this can be done because the data would all be available off the shelf and we can simply use it. So this was identified as level 1. So I don't want to go into all this details. Then it is the mitigation and adaptive pathways that a system can develop. So basically what we did in the previous workshop was to identify 2 major goals wherein the country had to create a database on hazards and exposure, and then they could use some online tools that are directly available and then use it to create a regional framework. Okay, so now then we also listed out the minimum data sets that are required to undertake a CV study. So if they didn't have it, they could collect it. So this was one step that was already also done. And the way forward was listed as we have a regional leadership summit which would help identify all those that I have identified in red. For example, define what vulnerability that needs to be addressed on priority basis in terms of physical, social, economic, environmental vulnerability, taking into account the hazards identified. And that is what we are going to do this afternoon. And define the vulnerability parameters, data needs, source accuracy, gaps, etc. Define the methodology for each vulnerability, identify the possibility of data sharing, and capacity building weeks. So these were identified as the way forward in the previous workshop, and that's what we are doing now. So now we have actually identified okay, we have identified 4 groups here. Physical vulnerability, we have erosion and inundation, socio-economic vulnerability and ecology, and we have identified people we know who have worked in all this, and those names are there. I have also, we have circulated one form in which you were asked to give your interest. So based on that, we also put you into different groups. I'll share that slide during lunch, so that we have group discussions in the afternoon wherein you can discuss on these major things. That will also be circulated as slides. So basically for each vulnerability you are supposed to identify the parameters and give a broad methodology that can be adopted by a country and things like that. So this is what is planned in the afternoon.
Thank you, Dr. Usha. Now that we had a packed formal session, it's time to have some food and organ before coming to the program. So the afternoon has dedicated for this will be taking care of the activities with our those for here for activity participating of course we are going to see. So for the moment break for lunch and in the same place as we had yesterday. We have not got any